Hello and welcome to the demo of engineering an XML utility application. The whole idea behind this exercise would be to give a better understanding of engineering software at a professional level, as well as give an opportunity to dabble in some aspects of the selected lifecycle development. We use the iterative or evolutionary model, known as the iterative and incremental development model, as the software development process model. It consists of the following four phases of inception, elaboration, construction, and transition. Each iteration comprising of a period of 4 weeks, overall giving around 2 to 3 iterations. Now that we've zeroed in on the process that we're going to use, let's talk about the tool. We know that XML is currently the most sophisticated format for distributed data. In fact, it's still an evolving and popular technology, opening up new possibilities for highly efficient search engines and intelligent data mining. Banking on this awareness, the idea was to build a simple utility application that touches both content and presentation aspects of XML. The application would have to be GUI-based, lightweight, and data-centric. It would have to facilitate the usage of simple XPath queries on any XML document, as well as have the ability to transform into another format using XSL. Additionally, it would have to have features that would support checking if the document is well-formed, as well as contain a certain knowledge component in an application for developers or students who wish to understand or gain some practical knowledge using XML. A good feature to have would be a graphical illustration of the structure of the XML document that has been loaded. That being said, now that we have elicited our requirements, it has been transformed into 5 user stories, as we can see on the screen. Let us now move on to the estimations. As seen below, we have enlisted the user stories and I have come up with an initial estimate of 40 days. These estimates are based on the following assumptions that have been enlisted here. I was able to resolve one of the assumptions, but 2 of them were still in unresolved format. That means they were the remaining risks. So let us go ahead and look at our iteration plan. I have chosen an iteration plan of 21 days each. As per my estimates, it would take 40 days to complete the entire project. On looking at the user stories, I was able to divide it into 3 iterations. The first 2 iterations would cover the core functionalities. The iteration 3, however, is meant for feature implementation. So now we have our estimates in place. It's time to go into design. This was what I found most interesting in the entire project, designing the tool. Now, how was I supposed to go about this? I just started with a simple multi-tier design where there would be a presentation layer on top, a logical layer in between, and a data-centric layer that would just interact with the XML. However, the disadvantage of this kind of design was I wasn't able to have a plug-and-play aspect here. In case I wanted to go ahead and finish my tool, but later on decide to add a XML schema validation or certain other components, I would have to strip the entire tool. Making changes would affect every level possible. That is why I scrapped the design. I realized the biggest issue with my initial design was I was programming to interface and not implementation. This was certainly not a sound design. Then I came across a strategy pattern that we discussed recently in class, which seemed ideal for this kind of an application. Let's take a look at the strategy pattern. As seen in the diagram, a strategy pattern defines a family of algorithms that encapsulates each one of them and makes them interchangeable. The main components of a strategy pattern are the strategy that declares a common interface to all the supported algorithms. So here you can plug in the different types of algorithms, the concrete strategies. Now that we've selected our design, it is time to convert the strategy design template into an actual design of our application. I started thinking about the return types of each of the algorithms. It turns out that each algorithm will return some kind of an XML content as a string. It will also give some kind of an exception detail, that is some kind of a system exception provided it throws one, and it has to have a boolean which will indicate whether or not the algorithm has successfully completed. So I encompassed it into an entity object called the processed XML content, which each of the utilities would be returning. Now, the XML util strategy is an abstract class, and all these concrete classes are the implementations. The context would be an XML context, which will contain an instance of an XML util strategy. It is evident that this design supports a plug-and-play concept. It will help me add any new module just simply by adding a control here and adding an implementation here. It will not touch any other module, and neither will it affect any other levels. This will help me conform the testing to the only single module that I have added, and the errors will not travel across. Now let's move on and rethink our estimates. On looking at the design, I realized that before diving into implementation, I wasn't sure that whatever my estimates were to develop the XPath utility or XSLT utility were justified. I just wanted to make sure and do a proof of concept of both of them before I dived into the actual implementation. For this reason, I had to go back and modify my project estimates as follows. I added an extra estimate of 5 days for proof of concept, which helped me resolve another assumption, or rather I can say it helped me resolve a risk. That is why I was able to go ahead, implement the proof of concept, and after it was successful, and use the concepts used in the proof. This also altered my iteration plan to 45 days, and I had to put in a velocity factor of 0.7 to reach a logical conclusion for an iteration. So at the end of each iteration, I would help release the following user stories. Now that we are done with the design, let's move on to the implementation. The implementation has been carried out in C#, an object-oriented language that is supported in the .NET environment. As we can see the code structure, it is exactly similar to the design that we have come up with. In fact, each of the namespaces here denote the responsibility of the classes within it. For example, the strategy contains all the algorithms and the abstract strategy class within it. Now let me give a demo of the tool. This is the first screen that comes up when we run the tool. We have to browse and select an XML document. Let us select a normal, well-formed document. As we can see, the document has been loaded in the window below with all the elements. It also has loaded two different tabs, the XPath query tab and the XSLT tab. Let us try and put a simple XPath query. How about we query the names, the first names of all the people in this XML document. So as we can see, it has retrieved all the first name elements from the XML document. Now let's move on to the XSLT tab. The XSLT tab has a field where we can specify the style sheet and apply it to the selected document. Let me type out a simple style sheet that selects all the students who have taken more than one course. There. Now let me apply the style sheet. On applying the style sheet, I should get two entries, that is one a John Doe and a Joe Public, under the student list elements. Now let us see if our output verifies the same. Yes, as seen, the student list consists of a John Doe and a Joe Public. Now that we have completed our implementation, it's time to start testing. I have used the NUnit framework for this purpose. NUnit is the .NET version of XUnit. As we can see, I have come up with 3 test classes, each class testing the public methods of each algorithm that has been implemented so far in this iteration. Let me open up the XML checking utility test. This particular class tests the XML checking utility class, which checks for the well-formedness of a XML document. I have added 2 tests to this class. One, which tells us whether the file is well-formed, and if so, it should have no error. And the other one, which when a file is not well formed, it should definitely have an error. Similarly, I have added several other test cases for each of the implemented algorithms. I've also included a set of test data with some data which has to be used for the testing. Now let me run the test cases on the NUnit framework and see how the tests fare. As we can see, we have around 5 tests for each module. Now running the test, it has passed all the 5 tests. Finally, I'd like to tell you about the version control system I've been using. I've been using SVN as a version control and Google Code as a repository. I've been judiciously checking in all my changes from day one. And finally, I'd like to talk about the the folder structure in SVN. The trunk folder contains everything. It has the documentation, which consists of the project design, the project proposal, and the project estimates, the initial one and the modified ones. The POC folder consists of a proof of concept, which is just like a raw implementation of certain parts of the application that I was not sure of or that needed to be resolved as an assumption. Finally, the source code folder consists of 2 subfolders, which is the utility and the utility test cases. The XML utility class also has an executable that is in the bin release folder, which can directly be run to execute the tool. Finally, I would like to say that doing this project was really helpful. It helped me understand that software processes conform the development into systematic and organized process. Every phase, every step has a good reason. If I had to change something or do something differently, personally, I would like to say that I have to work on getting my estimates right, because that was what I found the most challenging to be, as I wasn't able to estimate how much time, or even close to accurate, how much time it would take me to program a particular module, which is why I had to stop midway and go back and do a proof of concept. Also, I would like to say that the most interesting part in the entire project was implementing the design, which I felt was quite a challenge, but it was very interesting. Finally, I'd like to say thanks to Dr. Kagbi, who has helped us understand all these concepts so well and made the subject so interesting. I hope this was helpful. Thank you.